Okay, 24. A psychologist wants to determine if there is a linear relationship between the number of hours a person goes without sleep and the number of mistakes he or she makes on a simple test. The following data is recorded. Hours without sleep, that's our independent variable, x values. The number of mistakes on the test, y, dependent variable. The following data is recorded. Determine the regression line equation and plot the regression line on the scatter plot. Two ways you can do this. You can do this with the formula or just in the calculator. As usual, I'll show both. So let's look up the formula for our regression line so we can determine that equation first of all. So on our formula sheet, chapter 10, correlation and regression, there's the regression line equation, y prime equals a plus bx, and the components, a, this gives us a, this gives us b. Okay, so let's write this formula and then use it. So the equation of the regression line is y prime equals a plus bx, where a is sum of y times the sum of x squared minus the sum of x times the sum of xy over n sample size times the sum of x squared, well, the number of pairs rather, minus the sum of x squared. It's a lot, right? Yes, I know. And b is, well, why'd I put that? Silly. So b is n times the sum of xy minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x squared. Denominators are the same. Okay, here we go. So again, I'm going to use like a hybrid formula calculator approach because remember, with the correlation problem before, we can get these sums, we can get all of these sums here by inputting our data into the calculator and then using two variable statistics. So let's do that. Let's enter all of these values, the x values in L1, 32, 38, 48, 24, 46, 35, 30, 34, 42, and making sure that we enter the L2 values, the y values, corresponding to those x values. So 6, 8, 13, 5, 7, 6, 5, 8, 12. Hope those are right. Let's double check. 32, 6, 38, 8, 48, 13, 24, 5, 46, 7, 35, 6, 35, 34, 8, 42, 12. Perfecto. Now I go back to stat, over to calc, to do a calculation with two variable statistics. That'll give me all these sums that I need. Hit enter. Okay, so let's write these on the side. I'll write them, where should I write them? I'll write them up here. I'll create a little section up here. I know I need the sum of x. I know I need the sum of y. I know I need the sum of x squared. Let me extend my little area a little bit. I know I need the sum of y squared, and I need the sum of xy. Okay, so the calculator should give me those. The sum of x is 329. What else? Sum of x squared, 12509. And these values are all going right in there. N is 9, we know that. We have 9 pairs. The sum of y is 70. The sum of y squared is 612. And the sum of xy, we've got that too, 2698. Okay, so we have all our sums. Let's substitute them in this formula here. I'll use different colors for each one. So the sum of y is 70 times the sum of x squared, 12509, minus the sum of x is 329. Sum of xy is 2698. Over, and there's 9 pairs, 3, 4, 5, 6, 7, 8, 9. 9 times the sum of x squared is 12509, minus the sum of x squared, so 329 squared. Now, if you didn't have this function in your calculator to do that, you would have to add up all the x's, that'll give you the sum of x. Add up all the y's, that'll give you the sum of y. Square each of these, square each of them, and add that up, that'll give you this sum. Square each of these y's and add them up, that'll give you this. Multiply x times y. Each of those, add them all up, and that'll give you 2698. But I wasn't going to do that calculation, unfortunately. Okay, so let's do this. So I'll do the numerator in parentheses. So 70 times 12509 minus 329 times 2698. That's my numerator. Divided by, in parentheses, 9 times 12509, right, minus 329 squared. Okay, let's see what we get. Negative 2.767. Negative 2.768, we'll say. Okay, so A. Now B. Just want to be very careful that I write everything correctly. So 9 pairs times the sum of xy, that's 2698, minus the sum of x, 329, times the sum of y, which is 70, over, and again, times the sum of x squared, 12509, minus the sum of x, 329 squared. Okay, let's put this all in. Okay, numerator, 9 times 2698 minus 329 times 70, close parentheses, divided by, in parentheses, 9 times 12509 minus 329 squared, 0.288. That's my B. 0.288. Okay, perfect. So now that means the equation, the regression line equation, y prime equals a plus bx, intercept slope. So y prime equals negative 2.768 plus 0.288x. That's the regression line equation. Now, how do I do that exclusively in this calculator here? Here's how. So notice I already have in stat edit, I already have those x and y values in there. So I'll just go to stat simply, go over to tests, and down to linear regression t-test, linreg t-test, linear regression. This is exactly what we're doing. L1, L2, I'm not worrying about this here. Let's go down to calculate. And so for y equals a plus bx, here's a, negative 2.768 we said, and here's b, 0.288, the exact values that we found. Okay. All right, now we haven't finished answering this question, right? It says, and to plot the regression line on a scatter plot, which is another thing in itself, right? Okay. So let's draw this scatter plot. Let's give myself an X and a Y axis. So my smallest X value is what? 24. The largest one is 48. So let's do this by tens. Maybe let's do it by fives. Why not? Let's do it by fives. And I'll start at 20 and go by fives. So I'll start at 20. So here we'll start at 20. 20, 25, 30, 35, 40, 45, 50. And you can think of this as like a window, because I don't start, my first interval is not exactly, it's not the same as the other intervals. So I put this here to show that I started at a weird value. Okay, perfect. And the number of mistakes, our smallest is 5, and our largest is 13. So I can do this by fives, I think. Or maybe let's do it by threes. Maybe let's do it by twos. 2, 4, 6, 8, 10, 12, 14. Now this is not going to be exact, but it'll be something close to it. X value is 32, Y value is 6. Let's plot that point. X value is 32, Y value is 6, somewhere around there. Do this for each point. 38, 8, 38, up to 8. Next one is 43, 48, 13. 48, all the way up to 13. I think that's about right there. 24, 5, 24, 5. It started out looking like a straight line, right? But that one blew it off. 46, 7, 46, 7, somewhere around there. 35 is 6, 35 is 6. And I should have 9 points on here when I'm done, right? 35, 30. 34, 8, 34 to 8. And 42, 12. 42 all the way up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now the line of best fit is going to best approximate this scatter plot here and enable us to make predictions and what have you. So I think the best way to do this is to choose a let me label my axes. Hours without sleep and number of mistakes. Hours without sleep and number of mistakes. Okay, so I think our best bet would be to choose a value for X, substitute it into our regression equation, and then get that output for Y, get that predicted output for Y. We'll do that twice. I'll do it in purple. We'll do that twice, and then we'll connect those 2 points to form that line. I think we should use 25. So when X is 25, what's Y? And then maybe we should use 40. When X is 40, what's Y? So let's substitute those in. So we have negative 2.768 plus 0.288 times 25, 4.432. That's our output. And then if X equals 40, let's hit second entry. And just throw 40 in there. 8.752. So these would be my best approximations. So 25, 4.432. So I'll say that's somewhere like right under here. Somewhere there. And then at 40, we're at 8.7. 48, somewhere right here. I'll do my best to make a line that goes through these 2 points. It's a little difficult to do with this software here. So here we go. Oh, yes, sir. It's pretty good if I may say so myself. So there's our regression line. Y prime equals negative 2.768 plus 0.288x. And now we've finished answering the question.